Hello everyone, welcome back to my YouTube channel Tech Saplings. In this video, we'll see what are operators and its types. Before we start, I want you all to be aware that by end of the learning, we'll be working on mini project and also we'll be discussing interview questions. So be with me throughout this learning. Let's get started. Operators. Operators are special symbols which are used to perform various operations and calculations on values or variables. We are operating variables, understanding? So we became doctors now. We are operating on variables, not on patients. Next, types of operators. There are many types of operators. First one is arithmetic operators. Whether it is one or two lines of code, I want you all to practically do it for better understanding. So kindly, I hope all have installed Anaconda Navigator. If not, please install it. Else, as of now, do it in online editors. Type it. Only if you type, you get the understanding of what exactly is coding. Well, let's get started. Arithmetic operators. A and B are two variables I've taken and assigned the value 9 and 2 respectively. Now, first arithmetic operator, what we are doing is, operation is addition. A plus B. Subtraction, A minus B. 9 plus 2, 9 minus 2, 9 into 2. Division, 9 by 2. You get 4.5 as the answer. For division, it is forward slash. Modulus is something, be aware, percentage symbol. Modulus will return us the remainder. When 9 divided by 2, 2 fours are 8 and 1 will be the remainder, right? So modulus output will be 1. Next, exponentiation is something to the power. A to the power B, 9 to the power 2, 9 square, 81. Floor division is something where you use 2 forward symbol, 2 forward slash. Understanding? This is floor division. Wherein in floor division you get integer value as the output. Floor division will give us, return us integer value, not the decimal. Floating value will not be given. That is the difference. In normal division and floor division, this is what makes the difference. See here, normal division we get 4.5, whereas floor division we get 4 as the output. Done? Next. Comparison operators. It will compare two or more variables. Getting. We have taken two variables x and 5, assigned with the value 5 and 10 respectively. We are checking if it is equal, not equal, less than, greater than, less than or equal to, greater than or equal to. Equal to. For equal to, use 2 equal to symbol. Understanding? This is what condition is. 2 equal to symbol is comparing if it is equal or not. 1 equal to symbol is just for assignment. It is assigning the value. Remember, this is the major difference between 2 equal to symbol and single equal to symbol. Now equal to x equal to y. 5 is equal to 10. False. We get boolean value false as the answer. For not equal to, use exclamatory mark followed by equal to symbol. 5 not equal to 10. Correct. True. Less than. Is 5 less than 10? True. Correct. Next. Greater than. 5 greater than 10. Obviously false. Now, less than or equal to. 5 is less than or equal to 10. Less than, correct. One condition is satisfied. Or equal to, it is not equal to, but it is less than. We should get true as the answer. Next. Greater than or equal to. 5 is not greater than or equal to 10. False. Done. Next. Assignment operators. Assignment operators which are used are compound assignment operators. I have shown the examples here. I have taken a variable x, assigned it with a value 5. Now, for this, look here, plus symbol followed by equal to, which is equal to x is equal to x plus 2. X is equal to x plus 2 is written in short, x plus is equal to 2. Both are correct. Done. Now, 5 is equal to 5 plus 2. X value is 7. Now, x value is 7. Remember, I told you all when the same variables are used, updated or whatever newly it is storing, only that will be used. Correct? Now, x is equal to 5. Now, x became 7. Now, this 7 should be used here. Correct? X minus is equal to 1, which is x is equal to 7 minus 1. 6 will be the answer. Now, x is storing what? 5 or 6? It should store 6, the updated value 6. So, 6 is equal to 6 into 3. that is x will be 6. So 6 into 3 is 18. So now what x is storing? 18. Now next, x is equal to 18 by 2. 18 by 2. This is division. Normal division. It's not floor division. Therefore you get floating point. Note this. 9 by 2. There we got 4. Right? 9 by 2 is 4.5. Correct? In normal division. Whereas in floor division it is 4. That is what I am trying to tell you here. It is normal division. Therefore we get 18 by 2. 9.0. That's all. Next. Logical operations. Logical and logical or logical not are the three operations which we perform here. X and y are two variables assigned with the value 10 and 5 respectively. Logical AND is something when both the conditions are satisfied, only then you get the output as true. Else you will not get the output. And this is the keyword for logical AND. A-N-D. Done. Logical AND. X is 10, y is 5. 10 greater than 5. True? Yes. And 5 less than 10. True. Both the conditions are satisfied. I should get the output true. Next, logical OR. It checks if at least one of the conditions is true. At least one should satisfy to get the output as true. Now, x 10 is less than 5. False. Correct. OR is the keyword. Y is 5. 5 is greater than 3. True. One condition is satisfied. Therefore, we get the output as true. Logical NOT. It negates the condition. Negates means if you have 0, it makes 1. If you have 1, it makes 0. Understanding? If you have 0, you get the output as 1. If you have 1, you get the output as 0. Here, NOT is a keyword. NOT of x equal to 10. X is 10. In this case, what it is checking is, it checks if x is not equal to 10. But x is equal to 10. Correct. Therefore, we get true as the answer. Understood? Next. Bitwise operators. Bitwise operators, for this, these truth table are very important. I have discussed already and or, because and I told you all, right? When both the inputs are high, only then your output will be high. Else it fails. You get false. Your 0 means false, 1 means true. Or, I told you all, when either of the input is high, you get true, else false. Note, not table. If it is 0, it is 1. 1, 0. XOR table is also important. When you get the output as high, when either of the input is high, it should not satisfy this condition. When both the inputs are 0, you get 0. When both the inputs are high, you get 0. But either of the input is high, you get 1 as the answer. This is XOR, exclusive or truth table. Done. Now, before I begin with left shift, I want you all to understand what exactly is binary number or how to convert a decimal to binary number. Decimal values 0 to 9. Therefore, 10 will be the base value. Binary values are zeros and ones, which are machine codes. That is, our computer, our laptop, whatever, it understands only binary numbers. That is zeros and ones. All our, codes are converted to binary codes. Correct? That is what binary numbers comes into picture. 0 and 1. 0 or 1. That is 2. 2 to the base 2. Understanding? Now, 0 is written as 0 itself, 1 is written as 1, 2 is written as 1, 0, 3, 1, 1. This how this conversion is taking place. Let us see the example. Number 14. Decimal value 14 when converted to binary 1110. How this can be done? Simple. Just divide 14 by 2 continuously until and unless you get 0. That is 2 sevens are 14. No remainder. So 0. Put the remainder here. 2 threes are 6. 1 will be the remainder. Just put 1 here. Now 2 ones are 2. 1 here. Understanding? Now this cannot be divided, so put 0 and remainder will be 1 as it is. Understanding? So 1 write as it is and go in this upward direction. Don't come downward, upward direction. Therefore I get 1, 1, 0. 14 is the decimal. Binary is the equivalent value, which is 1, 1, 0. Done. Try working on this, but it is very important concept wise. Done. Just divide by 2 and write the remainder side by side. and write the answer, final answer, in the upward direction. Done. Now let us see what exactly is left shift. Left shift, remember, I have taken example 5, number 5, decimal value 5, which is written as, look here, decimal value 5 is written as 101. That is the same thing I have written here, 101. Now, left shift. Remember, in this 101, this is MSB, most significant bit, and this is LSB, least significant bit. In left shift, I have to shift MSB one step left side. So 1, which was here, will come and sit here. So 1, 0, 1. And this RHS, which is empty now, will be filled with 0. Therefore, I get 1, 0, 1, 0. Understood? Now, this is left shift once. When I'm left shifting it 2 times, two times if I want to shift, what I have to do is, this 1, which was here, will be shifted 2 times left side. So 1 will go and sit 2 boxes later. So this will be 1, 0, 1. This 0 was already there, and fill that 2 empty boxes by zeros. Understanding? By zeros. This is what left shift is. I have a small task for you all. Kindly work on right shift and check the output. Understood? Next, let us see a simple example. Now, I have taken 2 variables A and B assigned with 5 and 3 respectively, and equivalent binary values I have written in comments 0101, 0011. Understood? Now, bitwise AND operation. Bitwise means, now you can see here, 5 when represented in binary number can be written in 1, 2, 3, 4. 4 bits. 4 bits. I have written in 4 bits. Bitwise means I have to compare it like this, each bit of both the values. Understanding? Now, bitwise AND operation. Already I have shown you all the table, AND operation, OR operation, XOR, NOT, how it works. Kindly go through this. This is how it works. Bitwise AND. For this, the symbol is, or the keyword is, ampersand symbol. Understood? This symbol, just put this symbol. Now, A and B. That is, only when both the inputs are I, you get the output to be I. That is why you are getting 1, 1, 1, 0, 1, 0, 1, 0, 0, 0, 0, 0. Therefore, when bitwise AND these two values, you get B1. This B represents binary. So 0, B, 1. 1 should be your answer. Done. I have written the answer also here. Next, bitwise OR operation. Same. This is the symbol, which is a pipe symbol. Okay. Next, bitwise OR. 1, 1 will get 1. 0, 1, 1, 1, 0, 1, 0, 0, 0. You should get 1, 1, 1. Binary 1, 1, 1 should be your bitwise OR operation. Next, bitwise XOR operation. Exclusive OR between the bits, right? For this symbol is cap symbol. This is the cap symbol we use for bitwise XOR operation. Done. Same, XOR operation. What we'll get? When both the inputs are high or when both the inputs are low, we get 0. Either of the inputs are high, we get 1. Therefore, this we get 0, 0, 1, 1, 1, 0, 1, 0, 0, 0. That means 1, 1, 0 should be the answer. See here, bitwise XOR 1, 1, 0 is the answer. Done. Next, NOT operation. NOT of A. A is 0, 1, 0, 1. What NOT operation does is, if it is 0, it makes 1. If it is 1, it makes 0. Understood? So 1, 0, 1, right? 5 is nothing but 1, 0, 1. It becomes 1, 0, 1, which is A, will be written as 1, 1, 0. Understanding? Not of A. That's all. It will make 0, 1, 1, 0, 0, 1, 1, 0. That is what it just negates the value. If it is true, it makes false. If it is false, it makes true. Done. Next, left shift. I already showed you all the left shift for twice. See here, for left shift, 2 less than symbol, and this number after which I have written 2 represents I am left shifting it 2 positions. I showed you all this example, how to left shift 2 times. Done. Now right shift is something I have used only once. Right shift, A, that is 5 once. Only once you have to right shift. You will get the answer as 0010. Just right shift. Just try understanding it. right shift. Now, identity operators. Python has two identity operators, namely is and is not. You have a, a variable x. What is this? Square bracket. Remember, this is list. Done. List. I have listed it with 1, 2, 3, and I have assigned the same x to y, and I have declared another or assigned another list to variable z. Now, is operator checks if two values reference the same object. That is, one important thing is check the IDs first. IDs, if it is matching, only then is satisfying the condition. Reference means it should have the same memory location. Look here, ID of x, I'm getting same, I mean 1439, etc. And ID of y, I have assigned this variable to y. So I should get same, correct? The reference ID will be same memory location it is using. Therefore, I am getting same answer. Whereas z is another variable, though the values are same, but it is not having the same memory location. Look, the difference here. ID is not matching. If ID is matching, this will get as true. Else will get as false. So we'll check this. Is x y? That is, x is y. X is y, right? Because we have the same ID. We should get true. X is z. X is z. No. X and z are two different variables. I mean, we get the two different IDs. Therefore, we should get false. Now we will check what is not. Is not will not refer to the same object. That is, x is not z. Correct? X is not z. We should get true as the answer. If this statement or whatever I have written here, if I just change the variable, x is not y, I should get false because x is y. Understood? This is how identity operators work. Next, membership operators. Two membership operators, in and not in. Similarly, we had is and is not, which was identity operators. Here we have in and not in, which are membership operators. In returns true if the sequence with a specified value is present in the object. In this object, if that value is present, we get true, else we get false. Example, we have taken a variable numbers, which is assigned with, again, this is list 1, 2, 3, 4, 5, and in list is another variable we have taken. This in is the keyword. 3 in numbers, 3 in this variable, it is there. Yes, it is there. We should get true as the answer. You have to print it. Don't just leave as it is 3 in numbers. You will not get any output. You have to print if it is present or no. Or to check if the Boolean value, you have to print it. Next, not in list. Not in is the keyword. 6 not in numbers. Correct. 6 is not there in my object. Correct. In my list it is not there. Therefore, I get true here again. Understood membership operators? Let us have a look at ternary operators. Ternary operator, it is almost also called as, if else conditional operator. If else conditional because we have if and else. Done. The syntax is value if true. What variable you have to use or what string, whatever you have to use, that should be here. Then if condition will come here, followed by else, and whatever statement, what value you want to print if it is false. That is what the syntax is. Example, I have taken a variable and assigned it with value 18, age is equal to 18, and status is equal to, this is another variable which is equal to value if true. What you have to print should be mentioned here, that I am printing it as adult. If condition is if age greater than or equal to 18, you have to print adult. Else what you have to print? What string you have to print? Minor. Understood? Print status. Status. Since I have given age as 18, I'll get adult. If I had given here 15, I'll get minor. Remember, you can use user inputs. I taught you all in the earlier videos how to give a user input. Just to give age is equal to input of enter the number. That's all. Try giving user inputs rather than giving it static values. Done. So that you understand. So I am getting this output. This is what exactly is ternary operator. Thought of the day. Confusion is part of programming. It is part of programming, but as you increase your practicing skills, it will vanish. That is what I believe in. So have some hands-on experience, guys. So it's very important to start coding rather than just looking at these codes and understanding. So this confusion will vanish. Well, thank you so much for watching my video. Please stay tuned, like, subscribe, and share this video with your friends. Thank you for watching this video. Thank you.